everybody. Well, it's time to turn this into a laser cutter. Now, warning, danger Will Robinson. By the end of this video, I won't actually have this working as a laser cutter, okay? So don't get too carried away thinking, whoa, he's going to turn it into a laser cutter and it's going to cut. No, it won't. What I'm going to do is we'll just go through the process of recycling this hardware from a crappy 3D printer into a laser cutter with my 5.5 watt blue laser that we saw before. So let's proceed. Sorry about the ambient noise, it's raining outside and I've got a translucent plastic section in the roof of my shed to let some natural light in, but unfortunately when it rains it's quite noisy. Anyway, let's press on. So as I mentioned to you before, the construction of this machine is like this tab and slot arrangement. So you've got these bits here. I have managed to free these up a bit actually by soaking them in lubricant. So as you see, these parts all slot together like a little jigsaw puzzle. Get it around the right way, Benny. And then, as I mentioned to you before, this plate sits up in the back here, and just get that right, and that goes in there, and then these screws go through here, and this effectively ties the whole thing together, as you see. Okay, so now one of the problems that I've got with this is that, you know, you put a steel screw into soft aluminium like this plate and the chances of stripping a thread are quite high. But anyway, that's where we're at there with this. I don't think that there's any real point in like redesigning all of this stuff to make a whole new carriage and tra-li-la. I want to try and use as much of the hardware of this printer as possible, and I think that will mean cutting this front plate with the fans on it. We'll cut that down, and I'm going to have to leave a little lip on the top here so that this part of the tab and slot is still operational, because that holds this top plate down. So there we go. Now I've got a spare fan. Oh boy, life is good. So now we've got the carriage there. Now I'll just have a quick look at putting the laser in place here, and that's a pretty good fit actually. And that'll that very strangely is almost an exact fit. If it wasn't for the plate in the back here, this would actually go through the hole. Not that I need it to, because with this focusable laser, the focusing distance is fairly big, so I don't need to get this super close to the platform, so that's not a big drama. What I need to do is look at mounting this. So conveniently there's a set of mounting holes on the back here, and what I'm thinking of doing is making a mount that's adjustable anyway, so it'll be able to slide up and down a little bit, and that'll just help, I think, with the focusing side of things. So the other thing we've got to do here is modify this top plate so that we can get full travel around here. The laser's going to stick up proud of this plate because of the mechanism it's fixed in the frame. So we need to mark this out and cut away a section here as it was in the sort of second gen of this machine. So never has a tool promised so much and delivered so little than a jigsaw. The main problem with jigsaws is, as you would know if you've ever tried to use one, is that they wander. And so the only cure for that is to either set up a straight edge to run the saw along. That's one way to do it. Or just take it real slow. That's the other thing. So what I think I'll do. Nothing more disappointing than setting up a precision cutting arrangement like that and then having it go completely skew whiff on you. That's jigsaws for you. Capricious animals, and they don't like to be told what to do. So I've modded up that plate that I showed you before. That's the one that goes up here in front. Used to have the fans on it, now no longer. So it's time to do up a sketch of this base plate, which basically is what we're going to work off for the laser. Right, so before I start a CAD model, I like to build models of what I'm working with in CAD so that I'm getting an accurate representation of what I want. And in Fusion 360, the great thing about that is you can create models separate and assemble them all in one file. They don't have to be in separate files. Then you bring them into an assembly and blah blah blah. You can create them all in the one file and use the joints and so forth to assemble them. So what I want to work out obviously is the dimensions of this, and I'm just going to go for rough dimensions. I'm not going to try and make a super accurate model of the laser. I'm just going to go for this overall length, which lovely. And now to work out these centers. So these are holes to take a 3mm metric machine screw, and so I'm going to work out these hole centers, and the method that I use is using the verniers. I'll just go edge to edge and get that, which is 9. So when you're measuring like this, when you're just picking up the edge there and the edge of the hole, if you can see that with the verniers, all we need to do is to take that value off the verniers, which is 9, and add half the diameter of the hole. So in this case, we'll measure up the hole. It's 2.5. So that's adding 1.25 to the first measurement. So plus 1.25, 10.25. Now what? Okay, so I decided not to do a progress video of me making the model, or the models. We'll just hop straight into it. Now what I've done here is, as I said, I've created a model of the base plate and the laser. So there's the two pre-made components that we've got to use. And so the new components are this bracket, and if I hide the laser, we'll be able to see the adjusting plate. So here's my thinking on this. I'm going to have this plate attached to the laser. Got some adjustment slots in the back here. I'm going to put some cap screws through here. They'll go all the way through to the laser. Put some washers on the back of those, and then I'll be able to adjust the whole thing up and down. Now, one of the important things for me is that I've got room with this bracket to get to the lens, so I can adjust the focus on it. So that's quite important. Another thing you might notice here is that I've actually worked in components all the way through. So if you go over here to the browser and activate a component, then the other components sort of grey out and you've just got that component, and also you've got the timeline for that component. Probably a better example is here with the laser model. And each one of these, as you can see, has got a little coloured tab next to it. Now, this is something I haven't used before, but if we go down here to the bottom right of the screen, I've simply ticked this component colour swatch checkbox there, and that's then brought up all of this color coding, which is really handy. And the other thing to notice is down here on the main timeline, once we're in the top level component, which is the whole thing, you've also got those colors repeated down here, so you can see what segment of the timeline is that component, is, you know, where you've been working on that component. So that's really quite handy. So basically what we're going to print is we're going to print the yellow piece here. Could be any color when we print it. We'll find out what kind of material colors we've got, and the adjuster plate. Those are the two things we're going to print. And once again, I marvel at the age of 3D printing. Imagine where I'd be if I wanted to make this any other way, with a CNC machine, or, you know, whatever. What would I probably resort to? A bit of aluminium angle with some holes drilled in it and the ends bent over. Whoa! Here's something I have to tell you. These holes, they're all over the place. This set of holes here is not referenced to this extrusion. They've just been drilled here. This is not the center line. These are not evenly spaced from the edges. And that's my excuse, and I'm sticking to it. All right. So, fail, 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 fail. Finally. I guess this puts a lie a bit to my fabulous laying out technique. But honestly, these are very unreliable. And I actually contemplated, you know, starting from scratch with this and laying out some holes, you know, properly, and putting my own in. But anyway, I didn't go down that track. Here comes the family home from their perambulations. Come on, you little bastard! Right. And god damn those. It's funny with these things, all these little elements have to come together for it all to work. Case, like a Z-axis for a laser, and pretty darn expensive, even though it was a Chinese one. So that might be something to look at in the future, especially with a focusing laser, because if you want to cut through things with a focusing laser, you really have to move the laser, or move the bed, which we could do also, to achieve that. Anyway, there it is. There it is, as promised. A slightly movable, adjustable laser mount. Ooh. Time to offer this up, as we do. Us tinkerers and handy blokes, we offer up. Hey, pretty good. It's there. Okay, and now our other modified component, which is this plate, and then the backing plate, and the two screws. And one's longer than the other, and I could never remember which one went where. Anyway, get the longest one started first, that'd be easiest. maybe actually there wasn't actually a long and short one. Maybe when the thing was built they just put the wrong thing, the wrong fastener in there. And there it is. So there it is, in place, and it works. Well, at least the bracket works, and I can see that the adjustment is going to work. So next time we'll get into the electronics of this. I've got two boards. I've got a 2-axis board with a laser output on it, and I've also got a bunch of 3-axis boards that I could use. And in between now and the next video, I'll figure out whether I'm going to do the 2-axis board, which is, you know, dedicated to running a solid state laser like this, or I'll go with one of the 3-axis boards that I've got. So anyway, next time there's going to be smoke coming out of this. Whee! Onward and upward.